So the second question that we're going to look at here from the Unit A kinematics and vectors is a type that often trips people up, especially if you haven't done them in a little while. This question is about relative motion. So in this case, we've got a boat that can travel at 15 meters per second in still water. It's a pretty fast boat, and it heads north across a 150 meter wide river with a current of 2 meters per second to the west. So as always, let's start by drawing a picture. So there is our river. We've got a boat traveling at 15 meters per second across the river. We've got a current moving at 2.0 meters per second to the west, and the width of the river is 150 meters. Okay, so first part, how long does it take the boat to cross the river? And so the way that you can do this is you think about what component of the boat's velocity is going to be in the same direction as the distance across the river. So question A here, when you think about it that way, it actually works out to be very easy. So if you think about how much of the boat's velocity is pointing towards the north, well, we've got 15 meters per second pointing north, and the current is going to move it to the west at 2 meters per second. So really the only part that we have to worry about is this 15 meters per second, because this is the component in the same direction as that 150 meters. So if we want to figure out how long it takes to cross the river, there's no acceleration, so we have uniform motion, which means that we can just use v equals d over t. And so if we want to figure out the time is just going to be equal to distance over velocity is going to be equal to 150 meters over 15 meters per second, gives us a total of 10 seconds to cross the river. So it doesn't matter what the current is in this case, because the boat is pointing directly across the river, it always is going to take 10 seconds, no matter how fast the current is. Okay, second part of this question. How far downstream does the boat drift when crossing the river? And so, in this case, and again, we'll look at our little diagram here, the component of the velocity that is moving down the river is just this 2.0 meters per second part. This 15 meters per second part is not going to change how far down the river it drifts. The only part that changes it is this. So again, this 2.0 meters per second is the only part that pushes it down the river. And so again, in this case, we have uniform motion. And so again, we can just use speed is equal to distance over time. Except in this case, we solve for distance is equal to velocity times time. We know it takes 10 seconds to get across the river, so it's going to be drifting down the river for 10 seconds. And the only component that's causing that drift is the 2 meters per second. Multiply that by the 10 seconds. And we find that it's drifted 20 meters down the river. So really these two parts, the part that is moving north-south and the part that is moving east-west, are completely independent from each other. Actually, one thing that we should add here is the direction, and it has moved to the west. Okay, third part of the question. What direction would the boat have to aim to land directly across from where it began? So for this third part, instead of pointing directly straight across the river, the boat is going to have to point some direction to the side so that it ends up directly across. So say we started at point A, we want to end up at point B, and if we aimed directly from A to B, like we said, we'd end up 20 meters downstream. So instead we have to point off to the side in some direction. And so what direction is that? Well, it turns out that we can calculate this direction because the magnitude of this part of our vector is still going to be 15 meters per second because that's how fast the boat is moving compared to the water. We've still got a component of the velocity that is pushing the boat down the river at 2 meters per second. And conveniently, we can use those two values to figure out what this angle is here. And so that angle there is just going to be the arc sine, or the inverse sine, as people often like to say, of 2 meters per second divided by 15 meters per second. We could have gone through and figured out distances and that sort of thing instead, but it's going to work out the same if we use the speeds here, so we might as well save some time and do that. If we figure out the arc sine of this, it is 7.66 degrees, and if we want to be precise, that is 7.66 degrees east of north. So if you head in that direction, you should end up directly across the river. So the key for these kinds of questions is, again, split things into two components. So look at either like the north-south all by itself, and then look at the east-west separately. And so it's important to keep those apart. And that's something that we often forget when we approach these questions again after not having seen them for a little while.